everyone. Welcome to this week's Power Corner. I'm your host, Aalyia Shaukat, Editor-in-Chief of Power Electronics News. Today we'll be speaking with Suman Narayan, CEO of Cyient Semiconductors. Welcome, Suman. Glad to have you here.
Thank you for having me on your show.
So, from what I understand, Cyient Semiconductors is a subsidiary of Cyient, an engineering solution company headquartered in India. Cyient Semiconductor launched last year in April as a fabless design firm to focus on custom ASICs. What was the catalyst for this decision?
Yeah, so Cyient actually built a strong semiconductor capability over the years, especially after acquiring Ansem in 2018. The operating inside a services organization like Cyient kind of limited our ability to build reusable IP, pursue pure semiconductor opportunities, and structure the business for long-term silicon lifecycle commitment. So we launched Cyient Semiconductor in April, as you said, in 2025 to really kind of capitalize and scale the IP assets. We could execute acquisitions like we did for Kinetic Technologies. We could form deep ecosystem partnerships like we've done with Global and MIPS and Nora that you saw, and really own the full ASIC lifecycle from architecture to production. The shift from a utilization-driven services model to an IP and product leverage custom silicon model is what we wanted to strive for over time.
Okay, and moving forward from that, the custom ASIC market is a large one. And can you describe Cyient Semiconductor's unique advantages in custom ASIC?
Yes, so I think maybe we can look at it as, four key ways we differentiate ourselves in the market. We go all the way from architecture to production in a lot of the cases. So we start with the deep analog power expertise, with the Ansem acquisition and Kinetic. We've got good automotive grade mixed signal power and power conversion IPs, and we have 100 patents and about 250 ASSPs now with the acquisition. But also, we've done over 25 ASICs and we've shipped millions of units with the ASIC capability. Then our collaboration, if you look at where we are with intelligent, mixed signal ASIC opportunities, where we actually integrate, four blocks. So we're very strong at integrating an MCU CPU block, the power block, the analog mixed signal block, and the RF block. So if you look at some of the work that we did for our smart meters in India, we were able to quickly put together all our internal IP blocks. We have about 600 IP blocks and really come together and develop silicon quickly. The third is we're well aligned with the semiconductor ecosystem, all the way from the partnership with GlobalFoundries, the partnership with Navitas, really enables us to kind of leverage a lot of the foundry business where we are a one-stop shop now for foundries. So if there's an OEM who needs to go buy wafers, they can just buy the wafers from us. They don't have to go anywhere else to buy wafers. So we're just a one-stop shop. Makes life much easier for the OEM to just come to us and say, we want to build this chip. Here are the four problems, and we just want to see the final chip, and we want to integrate our custom IP in your chip, and we would be happy to do it. So it's really a turnkey. The fourth would be the turnkey lifecycle model. So as we said, from architecture to IP integration and silicon realization to production test, and our partnership, we just go from end to end on the lifecycle for the business.
Thank you. Maybe you could describe what a typical engagement looks like for a customer that wants to differentiate their product. What does the journey from first conversation to silicon look like?
Yeah, usually it starts with concept. It's almost like a napkin concept of, okay, we're buying 7 chips today. We have our own internal IP. We want to build this differentiated product. And I'm going to use the smart meter as the example. We want to bring the system cost down. We want to highly integrate this chip. We want to, reduce size. We want to reduce power, and we want to reduce cost, right? And we have this really good accelerator that we want to add in. We're like, fine, let's start with the system level architecture and definition. So that's how we get started. And then we kind of proceed towards what we call the commercial and technical structuring of the deal. We align on the model, on how we get paid, how they get paid, in the market. We have a good understanding of the market risks that we're taking, but also the product risks that we're taking. And often we kind of narrow them down to a 130, 180 nanometer and long life cycle commitments so that there's good understanding on both sides. The third is we get into the silicon development phase. It's the design to implementation and tape out. At every milestone phase, we engage with the customer. We have program reviews all the time to make sure that they're up to speed and they understand what the risks are, are we on track to execution, or are we not on track to execution? And finally, we get, where we work very closely is the validation production ramp. We want to make sure that we do our validation once the silicon comes back, but they also do their validation with the end application boards. And then we kind of correlate that with our test environment, and then we do the yield optimization, and then we ensure the supply continuity for them over time. So our real goal is to kind of reduce the BOM, improve efficiency, and create a silicon level differentiation for the OEM per se.
Okay, sounds like a pretty well-oiled machine there.
We're trying to.
Well, for my next question, you referenced this earlier. There's been a lot of partnerships since the launch of Cyient Semiconductors. You were mentioning the co-development with Navitas on GaN products for India's market, the MIPS partnership to develop a custom RISC-V based ASICs, and more. There's also the large Kinetic Technologies acquisition for a majority stake in the company. And from what I understand, as you were saying, they bring over 100 patents in the area of power conversion and protection. How does Cyient Semiconductor intend to integrate this IP into their custom ASIC engine?
Yeah, we're super excited about, not just the partnership with Kinetic, but also our partnership with Navitas, and increasing our presence in the power semiconductor space, which I think is going to grow rapidly, and we're building good expertise in the space across the board. For us, I look at the integration maybe in four layers with Kinetic, right? So first is the reusable hardened IP. If you look at voltage regulators, protection circuits, current sensing, gate drivers, so things that we can actually use as power macros for us, right? The second is we look at how do we leverage the intelligent power platforms. We can combine the Kinetic power IP with Cyient analog libraries, with our partnership with MIPS of the RISC-V cores, or with the ARM cores, and have maybe programmable intelligent power management ASICs. So that's a new offering that we can offer our customers. The third is we can also do GaN enablement, which is like the collaboration with Navitas, where we integrate fast switching GaN. We can integrate the drivers, controllers into our custom platforms as well. For us, the outcome is with the three layers. The final layer for us is how can we offer an intelligent, high efficiency power silicon platform that really kind of is better than some of the discrete components on the board to improve efficiency for power conversion.
Hmm. Thank you. Maybe we can, since we're talking about power, maybe zoom into data center power in particular. Could you describe the specific approaches that Cyient Semiconductor is exploring to improve efficiency from grid to core?
Yeah, so when we look at efficiency from grid to core, there's I'd like to partition it as two problems, right? So for the first problem is really the power conversion from the grid, and then the last mile conversion to the GPU. Maybe kind of split the problem into two ways. So today, our focus is like if you just look at from the grid to let's say to 6 volts. So you're going from 800 down to 6, you got 4 levels of power conversion. You end up maybe losing about 15%, on all these conversions. And as you know, the data center power becoming a huge problem, taking up, 3% of the world's electricity now to maybe 8% over time. There's a big focus on that portion as well. But there's a lot of focus on the last mile conversion for the GPU. So where we're addressing is, how do we do custom silicon for the first mile of conversion, not the last mile of conversion? As the GPU power kind of levels scale upward, the dynamic current draws, creates a lot of instability across the whole power delivery network, as you know. And so this this is what we're addressing, right? And we're addressing the three major challenges. One is the microsecond transient responses. So we integrate fast switching digital control and protection in the tightly coupled architecture to really minimize the voltage drops and maintain the stability. The second is we want to make sure that there's the grid to grid power integrity. This is where we have control architectures to monitor the peak currents across the AC/DC, and we offer that protection that's needed in that stage. And then the fast protection and monitoring, which is like, once you finish the protection, we want to make sure we're monitoring this so that we know when the peak currents are required for this, and we have the right fault protection, to prevent instability for the power collapse events in the grid to 6 volts. So we're solving the power supply or power delivery problem holistically from the grid to the last mile
Yeah.
of the GPU core, if you will.
Yeah. Um, Maybe we could move to industrial applications as well, because you have that partnership with MIPS. And can you give a concrete example of how integrating RISC-V with your analog IP blocks and custom ASICs improves the real-time motor control or robotic decision making compared to the discrete multi-chip approach?
Yeah, so I think the partnership with MIPS is really going to help us, almost like a dual die architecture where we've got the MIPS architecture. It's a hardened macro that we can use pretty easily. With MIPS we can enable a compute-enabled power architecture, right? So we can really integrate some real-time performance. So the risk, the advantage of that is, we can execute the control algorithms directly on the chip. We've got the analog sensing that feeds the control loop in real time. We have the protection and diagnostics integrated. We can adjust the PWMs for deterministic timings, like in robotic applications, for example. The benefits for us are like, sub 100 nanometer, 100 nanosecond loop response. We can reduce the EMI. We can have a 20 to 30% BOM reduction. It's a smaller footprint. And the big advantage with RISC, I think, is also not just the real-time performance, but also the firmware upgradability for offering differentiation to our end customers as well.
Um, so we have a lot of partnerships that we described earlier, along with Cyient Semi's established mixed signal analog IP. Um, how does all of this come together into a coherent product and technology roadmap?
That's a good question. So I think our focus is, we want to be today we're the largest custom silicon provider based out of India. And, our roadmap really centers around intelligent, efficient power silicon conversion. So if I look at the core layer, it's going to be our power IP, our GaN enablement. The Kinetic acquisition kind of provides us that core IP for power. The intelligence layer will be the mixed MIPS-based RISC-V CPU compute, the telemetry platform, and then we can work on the platform layers to kind of go after the multiple end applications, whether it be industrial automation, robotics, electrification, etc. So we're kind of building a domain optimized intelligent power platform that scales across applications for us.
Very interesting. Thank you. Thank you so much. Do you happen to have any final comments before I close out?
Well, thank you again for the time. This is a good dialogue and it allows us to kind of just walk through what we're doing in a simple format.
Yeah. Well, I appreciate it, Suman. It was great meeting you. Thanks for connecting. I'm excited to see what's in store for Cyient Semiconductors.
Thank you for having me again. Thank you so much.